The Hubble Space Telescope, a gleaming sentinel orbiting above Earth's turbulent atmosphere, has spent over 3 decades rewriting our understanding of the cosmos. Launched in 1990, it was built to peer into the deepest reaches of space to capture the birth of stars and the swell of galaxies billions of light-years away. Yet, in a twist of fate, this telescope, perched 340 miles above our planet, has turned its gaze closer to home, becoming an unlikely hero in the study of our own solar system. Where dedicated spacecraft were scarce or absent, Hubble stepped in, its razor-sharp vision and unblinking stability revealing secrets of planets, moons, asteroids, and beyond. Its story is one of adaptability, ingenuity, and the relentless human drive to uncover the mysteries of our celestial neighborhood. Picture the moon, our closest companion, hanging bright and familiar in the night sky. Its pockmarked face seems too large for Hubble's narrow field of view to capture in a single frame, a limitation that might have sidelined the telescope. But scientists are clever. In 2002, they turned this challenge into a triumph, using Hubble to study the moon's ultraviolet glow. By analyzing light reflected off its surface, they mapped minerals like ilmenite, a titanium-rich compound hinting at the moon's volcanic past. These observations weren't just academic. They guided NASA's planning for future lunar missions, pinpointing resources for potential outposts. Hubble didn't stop there. During the rare 2003 transit of Mercury, it caught sunlight filtering through the planet's thin atmosphere, revealing traces of sodium and oxygen. This technique, born from necessity, became a blueprint for studying distant exoplanets, proving that even our nearest neighbors could teach us how to explore alien worlds. Mars, the red planet, has long captivated our imagination with its rusty deserts and dreams of ancient life. While rovers crawl its surface and orbiters skim its skies, Hubble offers something unique, a global perspective. From its distant perch, it captures the entire Martian disk in a single image, something no orbiter can do. In 1997, Hubble documented a planet-wide dust storm that swallowed Mars in a hazy orange veil, revealing how these tempests reshaped the surface and churned the atmosphere. Over years, it tracked the ebb and flow of polar ice caps, shrinking in summer and swelling in winter, offering clues about Mars' climate cycles. One breathtaking sequence from 2001 showed the tiny moon Deimos, a lumpy rock just 9 miles wide, darting across Mars in a mere 30 minutes. This wasn't just a pretty picture. It helped scientists refine orbital models, ensuring future missions could navigate Mars' unpredictable skies. Hubble's images have guided rovers like Curiosity, helping planners choose landing sites where dust storms are less likely to bury delicate instruments. Beyond Mars lies the asteroid belt, a cosmic junkyard teeming with rocky relics from the solar system's birth. Hubble's keen eye has caught these fragments in moments of chaos and transformation. In 2006, it spotted asteroid 332P Murakami, a crumbling rock spewing dust in a comet-like tail. Scientists realized this was no ordinary asteroid. It was disintegrating under the relentless push of sunlight, a process called the Yarkovsky effect, where uneven heating nudges small bodies into new orbits. This discovery shed light on how asteroids evolve, some spiraling toward the sun, others flung outward to become potential threats. Another gem came in 2013, when Hubble observed asteroid PR 2013 P5, sporting not 1 but 6 dusty tails, like a cosmic pinwheel. The cause? Rapid rotation, fueled by solar radiation, was tearing it apart. These glimpses into the asteroid belt aren't just snapshots, they are windows into the violent processes that sculpt our solar system, hinting at dangers we might one day need to deflect. Jupiter, the solar system's Goliath, looms large in Hubble's story. Its massive gravity acts like a cosmic shield, snaring comets and asteroids that might otherwise menace inner planets. In 2009, Hubble caught a fresh scar on Jupiter's cloud tops, a dark bruise the size of the Pacific Ocean. The culprit? An unseen asteroid or comet fragment that slammed into the planet, releasing energy equivalent to thousands of nuclear bombs. This wasn't the first time Hubble witnessed Jupiter's protective role. The telescope's images of the 1994 Shoemaker-Levy 9 collision remain iconic. Fragments of a shattered comet rained down, leaving inky marks that lingered for months. These events weren't just spectacles. They underscored Jupiter's role as a gravitational guardian, sparing Earth from similar catastrophes. Hubble also turned its gaze to Jupiter's auroras, glowing ribbons of light at its poles, far brighter than Earth's. Unlike our auroras, sparked by solar wind, Jupiter's are powered by its own magnetic dynamo, fueled by the planet's rapid spin and its moon's interactions. In 2017, Hubble's ultraviolet observations during NASA's Juno mission revealed how charged particles from the Moon Io ignite these displays, painting a vivid picture of a planet alive with energy. Among Jupiter's moons, Ganymede stands out, a world larger than Mercury with its own magnetic field. In 2015, Hubble detected subtle wobbles in Ganymede's auroras, a clue that a vast saltwater ocean lies beneath its icy crust. This ocean, holding more water than all of Earth's seas, makes Ganymede a prime target in the search for life. Hubble's ability to spot such faint signals from 400 million miles away is a testament to its precision, turning a telescope designed for distant galaxies into a tool for planetary detective work. Another moon, Callisto, caught Hubble's attention in 2018 when it observed oxygen in its thin atmosphere, a hint that radiation from Jupiter's magnetic field is splitting ice into breathable gas. These findings don't just deepen our understanding of Jupiter's moons. They fuel plans for missions like ESA's JUICE, set to explore these worlds in the 2030s. Saturn, with its shimmering rings, has been a Hubble favorite since the Cassini spacecraft's mission ended in 2017. Without Cassini's close-up view, Hubble became the only tool for long-term monitoring of Saturn's atmosphere. In 2020, it captured a massive storm, a white tempest stretching thousands of miles across the planet's northern hemisphere. These storms, dubbed Great White Spots, erupt every few decades, and Hubble's images revealed how they churn Saturn's ammonia-rich clouds, offering clues about its deep atmospheric dynamics. The telescope also tracked changes in Saturn's rings, spotting faint spokes, ghostly streaks caused by charged dust particles dancing in the planet's magnetic field. These observations don't just keep Saturn's story alive. They help scientists model gas giants around other stars, where similar storms and rings might hint at unseen worlds. Farther out, Uranus and Neptune, the ice giants, remain elusive, visited only once by Voyager 2 in the 1980s. Hubble has filled this void, offering decades of insight. On Uranus, it tracked a colossal storm in 2014, a vortex spanning thousands of miles, its pale clouds swirling against the planet's cyan haze. These storms, rare for Uranus' usually sluggish atmosphere, hint at seasonal shifts driven by its extreme 98-degree axial tilt. Neptune, more dynamic, has been a Hubble treasure trove. In 2018, it revealed a dark vortex, a massive storm system nearly as wide as Earth, drifting across Neptune's blue expanse. Hubble also spotted high-altitude clouds of methane ice, glowing white against the planet's azure backdrop. These observations have refined models of ice giant weather, showing how their chilly atmospheres churn despite their distance from the Sun. In 2019, Hubble uncovered a surprise, a tiny moon, SR 2004N1, just 12 miles wide, nestled close to Neptune's larger moons. Its discovery challenged theories about how such a small body could endure in a chaotic orbital dance. Beyond the planets lies the Kuiper belt, a frozen frontier of icy relics from the solar system's dawn. Hubble, though not designed for such distant targets, has been a game-changer. Before NASA's New Horizons reached Pluto in 2015, Hubble provided the sharpest images of the dwarf planet, revealing a mottled surface of nitrogen ice and dark patches. It also discovered two of Pluto's tiny moons, STYX and Kerberos, each barely 10 miles across, guiding New Horizons' path through a crowded system. In 2016, Hubble turned to Eris, a Kuiper belt object rivaling Pluto in size. Its observations confirmed a reflective surface of methane ice, suggesting a geologically active world despite its frigid isolation. Another triumph came with 2014 MU-69, later named Erakoth, a double-lobed object resembling a cosmic snowman. Hubble's early images helped New Horizons zero in on this pristine relic, revealing a body untouched since the solar system's formation 4.6 billion years ago. Erakoth's reddish hue, caused by organic molecules baked by cosmic rays, offered a glimpse into the raw materials that built planets. Hubble's reach extends even to the heliosphere, the vast bubble carved by the sun's wind. In 2013, it studied how solar particles interact with planetary magnetic fields, shedding light on atmospheric erosion on worlds like Mars, which lacks a protective magnetosphere. These insights help scientists understand why Mars lost its water, while also informing the search for habitable exoplanets. Hubble also observed Enceladus, Saturn's icy moon, spotting water plumes erupting from its subsurface ocean. These geysers, rich in salts and organic compounds, make Enceladus a top candidate for hosting microbial life. By analyzing their ultraviolet signatures, Hubble confirmed their composition, paving the way for future missions to sample these plumes without landing. The Hubble Space Telescope's legacy in our solar system is a testament to human creativity. Designed to chase distant stars, it became an indispensable tool for studying our cosmic backyard. Its images of Mars' storms, Jupiter's scars, and Pluto's moons are more than scientific data. They are stories of a dynamic, ever-changing solar system. From the moon's mineral maps to the Kuiper belt's ancient relics, Hubble has shown that profound discoveries often come from looking closer to home. As it continues to orbit, potentially into the 2040s, it remains a beacon of ingenuity, reminding us that the universe's wonders are not just out there, but all around us. This adaptability stems from necessity. With few spacecraft dedicated to every corner of the solar system, Hubble filled the gaps. Its position above Earth's distorting atmosphere gives it clarity no ground-based telescope can match. Take Venus, a planet shrouded in thick clouds that hide its surface. In 2011, Hubble used ultraviolet light to study Venus' upper atmosphere, detecting sulfur dioxide and carbon monoxide swirling in its hellish winds. These observations helped scientists understand why Venus, once potentially Earth-like, became a scorching wasteland. The data also refined models for exoplanets with similar atmospheres, showing how Hubble's work ripples beyond our solar system. Mars, again, showcases Hubble's unique role. In 2003, when the planet was at its closest approach to Earth in 60,000 years, Hubble captured images so detailed they rivaled early orbiter shots. These revealed gullies carved by possible water flows, fueling debates about liquid water on Mars today. Such global views complement the close-up work of rovers, helping scientists piece together the planet's history. Hubble's time-lapse of Mars rotation also showed how its thin atmosphere scatters light, creating twilight glows that inform climate models for future human exploration. The asteroid belt, chaotic and ever-shifting, has given Hubble more tales to tell. In 2017, it observed asteroid 16 Psyche, a metal-rich body thought to be the exposed core of a shattered protoplanet. Hubble's ultraviolet data revealed iron oxides on its surface, supporting the idea that Psyche is a relic of planetary formation. This find shaped NASA's Psyche mission, launched in 2023, which aims to explore this unique world. Another asteroid, 99942 Apophis, caught Hubble's eye in 2020. Known for its close Earth approaches, Apophis showed signs of surface disruption, possibly from tidal forces during past flybys. These observations help predict its future path, ensuring Earth's safety. Jupiter's system remains a Hubble hotspot. In 2021, it captured Io, the most volcanic world in the solar system, glowing with sulfur emissions. These images, taken in ultraviolet, showed how Io's eruptions feed Jupiter's magnetic field, creating a plasma torus that fuels auroras. Hubble also revisited Europa in 2020, confirming water plumes with new spectral data. The presence of sodium chloride in these plumes strengthened the case for an Earth-like ocean, raising hopes for life. These findings guide NASA's Europa Clipper, set to launch in 2024, which will probe this moon's habitability. Saturn's rings, a cosmic masterpiece, continue to dazzle. In 2019, Hubble spotted seasonal changes in their color, caused by shifting ice particle sizes. These subtle shifts help scientists understand how rings evolve, offering clues about their age and origin. Hubble also caught a rare transit of Titan, Saturn's largest moon, across the planet's disk in 2018. The telescope's images revealed methane haze layers in Titan's atmosphere, refining models for its complex chemistry, which resembles early Earth's. Uranus and Neptune, often overlooked, owe much to Hubble's persistence. In 2022, Uranus showed a bright polar cap, a seasonal feature tied to its extreme tilt. Hubble's long-term monitoring revealed how this cap waxes and wanes, offering insights into the planet's quirky climate. Neptune's dark vortices, observed in 2020, showed unexpected stability, challenging theories about their rapid dissipation. These findings help scientists predict weather on exoplanets with similar compositions. The Kuiper belt, a realm of icy time capsules, continues to surprise. In 2018, Hubble studied Makemake, a dwarf planet with a bright, methane-coated surface. Its data suggested a thin atmosphere, a rarity for such distant worlds. Hubble also revisited Arakoth in 2020, confirming its stability as a contact binary, two bodies gently fused over billions of years. These observations rewrite our understanding of how planets formed, showing that slow, gentle mergers were common in the solar system's youth. Hubble's work on the heliosphere ties it all together. In 2016, it studied solar wind interactions with Jupiter's magnetic field, revealing how auroras respond to solar storms. This data helps model radiation environments on moons like Europa, where shielding is key to habitability. Enceladus plumes, revisited in 2021, showed organic molecules, further elevating its status as a life-friendly world. Hubble's ability to study these distant phenomena, without ever leaving Earth's orbit, is nothing short of remarkable.